Hello friends, welcome to my YouTube channel, and today we are going to prove that the integral of an odd function is equal to 0, or simply your symmetric integral is equal to 0. You can see that this is my integral over here, f of x dx, which varies from minus a to a. Minus a is simply your lower limit and plus a is simply your upper limit. Rather, going from minus a to a, what I can do is I can go from minus a to 0 and 0 to a. So I can write this integral as 0 to a f of x dx plus minus a to 0 f of x dx. Now you can see that if I sum up this is my first integral, this is my second integral. If I sum these both integrals, I will get this integral over here. Now this is really simple. For now we are just taking this integral. Let's suppose that I am just flipping the sign. I'm changing the upper limit and lower limit. So I will add a minus sign here, and I will get a into 0 into minus a into f of x dx. Now as we know that if x approaches to a, then minus x approaches to minus a. So if I want to convert this minus a into a, this is my upper limit. If I want to change this minus a into a, then I need to flip the sign of this x as well. So doing that, this is my integral over here. So my sign will be changed. After flipping the sign, what I will get is simply 0 to a f of minus x minus dx. So as we know that in odd functions, f of x is odd if f of minus x is simply equal to minus f of x. So as we assume that this is an odd function, as we are proving that the integral of odd function is simply equal to 0, so this is an odd function. So my integral from 0 to a f of x, I will add minus sign here and minus d of x. So this, I will take this integral over here. We can write this integral over here as 0 to a f of x dx plus minus this integral. So you can see that this minus sign will multiply with this minus sign, and minus will simply convert it to plus, and this minus is over here. This will multiply with this plus sign, and I will get a minus sign here. So this is my integral 0 to a f of x dx minus integral 0 to a f of x dx. Now you can see that this integral over here is same as this integral over here. So we can cancel this integral with this integral, ultimately getting 0. So that means that this integral over here is simply equal to 0, or your symmetric integral equal to 0. So this is the proof of this symmetric integral, which is equal to 0. This is how you prove that the symmetric integral from minus a to a is simply equal to 0.